Today's video is going to cover 3.7, everything exponents. Essentially, today's goal is to use or to simplify expressions using exponent rules. We've learned 6 major things, 3 rules, and then 3 other kind of property type things. Go ahead and pause this slide, review these 6 things. We're going to use all of them as we progress through these examples. Alright, this is the first example today, and I want to remind you that when simplifying expressions with exponents, there's no exact process. So a general rule is to follow PEMDAS, parentheses first, then worry about your exponents, which would be like your power rules, and then worry about your multiplication and your division, which is like your product rule and your quotient rule. And there's no real addition and subtraction here. I'm going to actually break up everything into smaller parts, and you'll see what I'm doing as I go through. So here we have negative 2m to the negative 5th into the 0 power, all to the 6th power, multiplied by negative 2m to the 2nd power into the 2nd power, divided by negative 2m to the negative 6th power into the 4th power. So the first thing that I'm going to do is I'm going to take everything in the numerator and I'm going to write it over 1. So here we have in parentheses negative 2 over 1 times m to the negative 5th over 1 times n to the 0 over 1, and all of that is being taken to the 6th power times, again, negative 2 to the 1st power times m to the 2nd power over 1 times n squared over 1. So everything in the numerator I just wrote, I broke everything up and I've rewritten it over 1. And I'm going to erase this because I need more room. Now everything in the denominator, what I'm going to do is write it under 1 because it's in the denominator. That means we put a 1 over it if we broke it into a smaller part. So 1 over negative 2, 1 over m to the negative 6th times 1 over n to the 4th. So I've broken this up into smaller fractions. Everything can be turned into multiplication. I've turned everything into multiplication. Things in the numerator are over 1. The things that were in the denominator are under 1. Now what I'm going to do is I'm going to simplify using order of operations. So I'm going to start with my parentheses. So here we have in parentheses, there's no like bases, so there's nothing for me to simplify. So my next step would be to worry about the exponent. We've got an exponent right here that we're going to use the power rule on. Before I do that, I already know that anything to the 0 power is 1. So what I'm going to do is I'm going to go ahead and erase this, and I'm going to write the 1, and it's a constant 1, the value of 1. So now I can go ahead and distribute this exponent to everything in here. So to the negative 2, and we've got m to the negative 5. Now I can rewrite this portion as negative 2 to the 6th power times m to the negative 30th power times 1 to the 6th power, which is 1, which isn't going to have any bearing on my value. It doesn't change anything, so I'm not even going to have to write it. Now I'm going to go ahead and drop the parentheses, and then I'm just going to bring all of this down. Now I brought all of it down. I should put these over 1. Let's get confused. Now what I'm going to do is I'm going to convert all of my negative exponents to positive exponents. So if you look here, we've got one negative exponent right here that I'm going to convert, and we've got one negative exponent right here that I'm going to convert. Remember, we convert by flipping it over the fraction line. So I can go ahead and rewrite this as negative 2 to the 6th, 1 over n to the 30th, negative 2 over 1, m squared over 1, n squared over 1, 1 over negative 2, m to the 6th over 1, and 1 over n to the 4th. Now my next step is to group these, group the parts that I can simplify together. In other words, I'm going to try to put all my m's together, I'm going to put all my constants together, I'm going to put all my n's together. So I'm going to go ahead and identify what's what. I'll use white to identify all the numbers. So we're going to condense these constant numbers. And then we're going to condense our variables. So here we have our m. And then we've got our n's that we're going to condense. And when I do that, all I'm going to do is everything that was, and this should be over 1, right? Classic mistake. It should be over 1. When we do this, all we're going to do is everything in the numerator is going to be multiplied in the numerator, and then everything in the denominator is going to stay in the denominator. So if there's multiple things in the numerator, for example, these numbers, this negative 2 to the 6th power was in the numerator, so I leave it in the numerator, and I multiply it to, this is in the numerator as well, to this negative 2. Those are taken care of. Now this negative 2 is in the denominator, so I'm going to leave it in the denominator. And I'm going to times that by what I get when I simplify my m's. So my m here is in the denominator, so I'm going to leave it in the denominator. Taken care of. M squared was in the numerator. Taken care of. And m was in the numerator. It's kind of nice that everything's being multiplied. Should have scratched this one out earlier. Classic mistake again. Kind of nice that everything's being multiplied. It makes everything very easy to manipulate and rearrange. N squared was in the numerator. I leave it there. And this n is in the denominator. I leave it in the denominator. Now what I'm going to do is just simplify the things that I can. First thing I'm going to simplify is these numbers. And actually, I'm going to put this in the calculator and let the calculator do that for me. I'm going to pause the video, type in the calculator, and I'll show you what I'm typing in the calculator. Okay, so I put all this in the calculator. We had negative 2 to the 6, which I put here. That was being multiplied to negative 2. And then it was being divided by negative 2. Now I can go ahead and hit enter, and I get 64. So this all simplifies to a 64. Now I can go ahead and simplify my m's. We've got 2 m's being multiplied to 6 m's. How many m's total? 8 m's. And I'm running out of room, so I'm going to go ahead and erase this now. We've got 8 m's right here. And now we've got m's that are being divided. Let's go ahead and keep the m's in the denominator so that they stay positive. So we've got 30 minus 8, which is 22. So we've got m to the 22nd power. This has all been simplified. This already was simplified. Now we've got our n's. These n's are being divided. Let's keep the n's in the denominator. 4 is larger than 2. 4 minus 2 is 2. So we can put n squared in the denominator. And then my answer is 64 over m to the 22nd, n to the 2nd. That was a 9-minute example. I took my time on it just to go through the steps. Try to squeeze in 2 more examples. And then hopefully after 3, that'll be enough. Here we have example number 2. So the first thing I'm going to do is break it up again. Everything in the numerator goes over 1. Everything in the denominator goes under 1. So u squared v to the 3rd negative 2 u to the negative 3rd v squared. That was all being taken to the 5th power. I leave those parentheses the same, and then I just put them all over 1. And then everything in the denominator, so we've got that negative out here, which is a negative 1. And then the v to the negative 2nd power. Okay, so now I'm going to go ahead and I'm going to distribute this 5 to everything inside the parentheses power rule, multiply the exponents. Okay, so I multiplied all of my exponents here by 5, except I didn't write this one right here because it was in the way. There was something in the way, so I couldn't. Negative 3 times 5 is a negative 15. And it's a different color for no apparent reason. Okay, now I can go ahead and convert all of my negative exponents to positive exponents. So really there's only 2, and I guess I should put these over 1, right? We've got the u to the negative 15th that we're going to convert, and we've got the v to the negative 2nd that we're going to convert. Now I'm going to go ahead and rewrite all of this by grouping everything that is alike, just like I did in the previous example. And now you can see we dealt with the constants in the front. Negative 2 was in the numerator, still is. And then this negative 1 was in the denominator. It's not really going to matter. In the end, we'll divide by negative anyways. Our u's, we had 10 in the numerator, u to the 10th in the numerator. We converted this down to the denominator to make it positive, so we put it in the denominator. Our v's, numerator, we converted this to the numerator to make it positive, so you can see everything is still intact. Now I can go ahead and simplify. I'm going to go ahead and plug this into the calculator. We've got negative 2 to the 5th power divided by negative 1, and we get a 32. So we've got 32 on top. These have been taken care of. Now we can go ahead and use the quotient rule. 15 is larger than 10. We're going to subtract them. U stays in the denominator. 15 minus 10 is 5. And now we've got our v's that are all in the numerator. We're multiplying our like bases, so we can add the exponents. V's being multiplied by itself. 15 plus 10, 25 times, plus another 2 times. Total, 27 times. And this is our answer. Okay, so the first thing that I'm going to do is I'm going to rewrite this all with everything separate. So we've got everything in parentheses. Go ahead and write these parentheses right here. Hopefully we fit everything in here. And then in the numerator, what we have in parentheses is negative u, which we can make a negative 1 actually, over 1, times negative u, dang it, I already took care of the negative, times u to the 4th over 1, times v to the 4th over 1. Close that little set of parentheses, that's to the 0 power, times negative 2 over 1, times v to the 6th over 1. Now I can take care of the numerator, or the denominator. We've got 1 over 2, and 1 over n squared. I'm going to go ahead and simplify my exponent. So I'm going to take care of the smaller set. Everything in here is being taken to the 0 power, so I can multiply that 0 out. When I do, what happens is everything that's to the 0 power, because 0 times anything, now these are all to the 0 power, they all become 1. So I can go ahead and rewrite my new expression just like this. So you can see here, 1 times 1 times 1 is 1. So all of these essentially are irrelevant. They don't have any impact on what's going to happen. So I've disregarded all of them. Now what I can do is go ahead and group the things that are the same. We don't even have to convert any negatives to positives because we have no negative exponents. So we've got our numbers that we can group, and then there's no v and there's no other n that we can group. So when we do that, what we get is we got a negative 2 on top, we've got a 2 on bottom, times we got v to the 6th over 1, times we got 1 over n squared, and that is all still being taken to the 5th power. Before I take my power to my exponents, I'm going to go ahead and I'm going to simplify this division. Negative 2 divided by 2 is a negative 1. Now that I've done that, what I can do is take my power to my exponents inside the parentheses. Negative 1 times itself 5 times is a negative 1. Times v to the 6th, or times v to the 30th, sorry, all over n to the 10th